Assalamualaikum warahmatullahi wabarakatuh. We are from Pegasus Group and this is our team members. Our group choose Windows 10 to see the response to different TCP flags in the network. Before we go to the scanning part, I will briefly explain the use of TCP flags and also the types of TCP flags. So, TCP flags is used to notify a particular state during a TCP communication. It can also be used for troubleshooting purpose. So basically, TCP flag is used to notify about the condition of TCP traffic. Next, I will explain types of TCP flag. There are 9 types of TCP flags. 6 flags which are commonly used in the network and another 3 flags is for special case. I will go to the 6 flags which are commonly used first, then we go to the another 3 flags. So the first one is SYN flag, next is acknowledgement, reset, finish, push and urgent. For SYN and ACK flag, they are used to initiate connection. Reset and finish are used to abort connection. For push and urgent flag, they are used for data transfer. So I will explain one by one. SYN flag is the first flag that every host on the network used to initiate a connection. Next one is ACK flag. This flag is sent after the initial SYN packet sent by host. The next one is reset. Reset is used to terminate connection forcefully, and FIN flag is similar to reset, but FIN works for gracefully termination of connection. For urgent and push flag, they are doing the same thing, but the major difference is urgent flag does not wait in queue, and push flag need to wait in queue. Urgent flag immediately sent to the destination without delay in buffer. Telnet is an example we can say for urgent flag. For push flag, it need to wait in queue. If there is already ongoing process of data, so push flag need to wait in the queue. It requires the data stored in TCP buffer. We can see that FTP is example of push flag. So we go to another 3 additional flag. Generally, these 3 flags are only made for congestion purpose. ECE flag. ECE is explicit congestion echo. This flag indicates host is ECN enabled. Whenever this flag is on, this indicates host is ECN enabled. ECN is explicit congestion notification. This flag indicates that ECN capable during TCP handshake. So next is ECN nonce. ECN nonce flag used for concealment protection of ECE. Means if there is congestion in the network and that need to be notified to the sender, so this ECN nonce flag is used to notify that there is ECE congestion notification in the network. So the last one is CWR flag. CWR is congestion window reduced. So this flag used by the sender to notify the receiver that sender has received ECE flag. So we move to the next part.
To do now is I am going to do a ping scan, and I'm going to assume that all ports are online. So this is the command and -n -192.168.115. So as you feel further, we have seen a few results here. Our IPv4, which is this is 192.168.0.115, and let's come and run the command. Okay, so we have seen here there are a couple of available ports, so we have to take note because we are going to use one of the available ports for our next command that we are going to key in. So I will be choosing the first one, which is port 135. Then let it run. Then run the command. So it's going to take a while. So you have to be patient with it. So now we are going to observe the TCP flags here. So there are a number of TCP handshakes here. We have seen push, acknowledgement, SYN, ACK at the above one here. So it mentioned that our our port is open. It's a form of TCP. This is the response that we get. It mentions keep alive. Right. So moving on. So this is I am testing on an open port. So it mentions here this port is open. So it mentions here that our port is open. So let's check the behavior here. So we have seen a couple of positive replies here. Common close port here is port 80. So let's try port 80 here. So you can see the behavior here. So it has pushed into acknowledgement for the port. Key in the previous. So we have to do a little bit change here. So we are going to send an acknowledgement this port under this IP address. So the open port that I tried just now was 445. So, alright, so it's going to be an unfiltered one. So it has changed its status here from open to unfiltered one. So Windows scan for our port. So let us check what did nmap reveals to us. A few resets here because Windows scan and acknowledgement scan they will actually send the same package. Now we are going to do the MyMon scan. So we are going to test it also with our open port. So since it's closed, we don't actually see any response. We should have been getting finish or acknowledgement. So let's check if it's actually there for the finish and acknowledgement. So we have seen acknowledgement here, a few acknowledgements here. Command. So this one is to observe randomized behavior that is shown by our chosen operating system. This is the Windows 10. So the behaviors might be different from other OS. So there are a couple of null responses here. The command, if you can see it. We have seen a couple of reset acknowledgements here. So this is the reset acknowledgement. We are going to enter the xmas command. The xmas command should show us fin, push and urgent command set to 1. We have seen acknowledgement. So far what we have seen is that we get fin push. How do we do it? So we have to enter this command. So let's do a half scan and let's do an acknowledgement command. And here, I would like to change 139. So and I will hit this. So it says equip. So we cannot combine these commands like this. So one of the ways that we can do it, so we can do it using the command scan tag. There is one in acknowledgement here. So the acknowledgement here is set to 1. So this is the behavior that is activated in this white sharp. Have a reset here. Reset. Steam here. Reset it as 1.
Okay, next TCP scan using Python. We must ensure that the code don't have an error before running it. After the code run, you can enter the IP address and the TCP flag. And you must capture the flag using the Wireshark and filter into the specific IP address that you send. We can see the flag that Wireshark capture from 1 to 256, and we can see the type of the flag. The packet, when we send one packet, we are requesting the fin flag. When we send 2 packet, we are request the SYN flag. 4 packet, we request the RST flag. 8 packet, we request the PSH flag. 16 packet, we request the ACQ flag. And 32 packet, we request the VRG flag. And for the 64 packet, we request the ECN flag. 128 packet, we request the CWR flag. And the last one, when we send 256 packet, we request the NAM flag.
So that's all from our group. Thank you for listening.